This is the screencast for section 7.1, example 1. Interpreting a velocity function, we're going to basically be using an integral as a net change, and you've seen some of this, but we're going to explore it more in an application format in this section, where integral is a sum or a total of something, and we're going to use it as a net change. So first we're going to do a little bit of a review here. Figure 7.1 shows the velocity, so ds dt, the derivative of position. So I'm going to make sure and label that right off the bat so I have a constant reminder of which graph I'm looking at. And then it's got this equation here. Alright, so then we want the domain between 0 and 5 seconds, and we want to describe the motion. Now remember, describing the motion is a very vague set of directions. The AP exam will never ask you to describe the motion. I will never ask you to do that on a test. There's just way too much involved in that. So if you stick to these 6 categories for classwork purposes, that should be just fine. So when is the particle moving left? Well, the particle is moving left when velocity is less than 0. So I need to find that 0. And I did that using my calculator. It was 1.255, whatever. So when is the particle moving left? Or in other words, when is v of t less than 0? That's going to be on the interval 0 to 1.255, between 0 and 5 seconds. When is it moving right then? Well, that's going to be after that. So v of t is greater than 0 or positive from 1.255 to 5. Where is this change of direction taking place then? Well, that's going to be at that 0. Not all zeros result in a change of direction, but this one does because the velocity changes from negative to positive. So the particle was going left and now is moving right at x equals 1.255 seconds. Acceleration is going to be directed to the left when the acceleration is negative, which means the velocity would have to be decreasing. But here the velocity is never decreasing, so never. And then that way, when is the acceleration directed to the right? Well, that's all the time because the velocity increases the whole time between 0 and 5 seconds. So when does the non-directional acceleration occur? Never, because there is no max or min of v of t. The derivative of v of t, or acceleration, will never equal 0. In other words, v of t does not change from increasing to decreasing or vice versa. Now this now try problem is going to be split A, B, and C amongst the next 2 examples as well as this one. So we're going to just tackle 1A here. The function v of t is the velocity in meters per second of a particle moving along the x-axis. Use analytic methods to do each of the following. So A, determine when the particle is moving to the right, to the left, and stopped. So this is a better example of a describe the motion. It's a more specific way. They ask you specific things they want you to describe. Alright, so v of t equals 5 cosine of t, and we want t between 0 and 2 pi. So let's just pretend you're not allowed to use your calculator. Well, I know that v of t equals 5 cosine t graphs to be looking like something like this. So at 0 it's going to have a height of 5, at 2 pi it's going to have a height of 5 because it's a vertical stretch by 5, and we've got this lump in the middle that's below the x-axis. So determine when the particle is moving to the right, left, and stopped. Okay, so I could use my number line test. I mean, yeah, you can just see it from the graph, but either way. And my critical values are the left endpoint 0, which produces a y value of 5, pi over 2, which produces a y value of 0, 3 pi over 2, which also produces a y value of 0, and the other endpoint 2 pi, which produces a y value of 5. So when I test each of those intervals, I get positive, negative, positive, just like I would expect in the graph. Which means then that the particle is moving to the right when v of t is positive, so between 0 and pi over 2, and then 3 pi over 2 and 2 pi. And I can't include those as endpoints because those are very definitely positive values at those endpoints of the interval. The particle is then moving left from pi over 2 to 3 pi over 2. I cannot include pi over 2 or 3 pi over 2 because that's actually when the particle has a y value of 0 in the velocity. So it's stopped, which brings me to my last part. It's stopped at t equals pi over 2, comma 3 pi over 2 seconds.